What is going on, everybody? Got another video here for you. Auxiliary equations with repeated or complex roots. Auxiliary equations, characteristic equations. We'll call them auxiliary equations in this video. So the video right before this one, let me see what I named it. It is named higher order homogeneous equations. That lesson goes with this one, so you can watch that one. It's the same thing, except in this one, notice we have our auxiliary equation has repeated roots or complex roots. The video before this one is where the auxiliary equation had unique solutions, so the solutions were different, and they weren't complex, they were real solutions. So this is just a continuation. I could have done it all in one video, but I didn't because the book splits it up into two sections. All right, so the solution of this differential equation here, a naught d2y plus a1 dy plus a2y equals 0, with auxiliary equation a naught m squared plus a1m plus a2 equals 0. So if this is the auxiliary equation here and we have equal repeated roots, so m1 and m2, the two roots are equal to each other, our solution is y equals c1 e to the m1x plus, now here it is, x times c2 e to the m2x. So if you watch the last video, in the last video there was no x here. Okay, that was the difference. This x right here was gone, and that was your solution. But when we have repeated roots, you got to multiply the x times that. All right. And then if we have complex roots, m1 is alpha plus beta I plus m2 equals alpha minus beta I, then our solution is y equals c1 e to the alpha x cosine beta x plus c2 e to the alpha x times sine beta x. So you've got to know this one, and this one, and that's it. And then you got to know how to solve an equation, and you should know how to do that by now. So let's go ahead and get started. We've got, I think, 8 examples to work. It's pretty good examples. Watch them all. Okay. All right, so let's solve. So we've got d2y minus 4dy plus 4y equals 0. So our auxiliary equation is m squared minus 4m plus 4 equals 0. And so this will factor to m minus 2 times m minus 2 equals 0. So we get m equals 2 or m equals 2. And you can see we have repeated roots here. And so, you know, here's our solution. It's y equals c1 e to the m times x, so 2x, plus, and we got the repeated root, so that's x times c2 e to the 2x. And there's your solution. So, I mean, you can see it's pretty easy. It's not bad at all, is it? So let's look at the next one. All right, so this one we've got d plus 2 squared y equals 0. So what this is doing, this is telling us that d plus 2 equals d plus 2 squared equals 0. So you can see we're going to have the repeated roots because we've got two factors of d plus 2. And if it helps you, you can write it like this. I'm sorry, I don't know why I put a d. That should be m. So this is our auxiliary equation, and you know, if it helps, write out both factors. So we get m equals negative 2 or m equals negative 2. And so it's going to be the same thing. Y equals c1 e to the negative 2x plus, because it's a repeated root, x times c2 e to the negative 2x. And there's your solution. Oh, I don't know what happened there. All right, what about this one? All right, we got the second derivative minus 10 times the first derivative plus 25y equals 0. So our auxiliary equation m squared minus 10m plus 25 equals 0. This factors m minus 5 times m minus 5 equals 0. And so m equals 5 or m equals 5. And look, I mean, if you wanted to, instead of writing it like this, you could write m minus 5 squared equals 0, m equals 5, and just know that you have two roots, okay? But like I said, if it helps you to do this, to write it out like this, that's fine. It might be a little easier for you to see. And so that's going to give us y equals c1 e to the 5x plus x squared, not x squared, x times c2 e to the 5x. And here's your solution. All right, so that's pretty easy there, not bad at all. Kind of makes you think you're not even in a calculus or differential equations class, does it? It's so easy. All right, so let's look at this. So here we've got m squared minus m plus 1 equals 0. Now this doesn't factor, does it? Okay, so we can solve this using quadratic formula. So I've got m equals negative b, because remember, a is equal to 1, b is equal to negative 1, and c is equal to 1. Remember, a is the coefficient in front of the squared term, b is the coefficient in front of m, and c is your constant. All right, and that's plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so we get m equals 1 plus or minus, and that's going to be, that's 1 minus 3 is negative 3, square root of negative 3 over 2. And so we get m is equal to 1 plus I square root of 3 over 2, or m equals 1 minus I square root of 3 over 2. Remember, the negative sign under the radical, the square root of negative 1 is I. And so you've got your two solutions here. Now, remember up here in our solution here, we have to know what alpha and beta are. And I'm going to copy this and bring it down. All right, so I've got it copied down here. So we've got to determine what alpha and beta are. And remember, this is your solution where m is alpha plus or minus beta I. Okay, so you don't have to do this, but if it helps you, do it. Write m equals 1/2 plus square root of 3. See if I can't write. Square root of 3 over 2 times I, or m equals 1/2 minus square root of 3 over 2i. So you can split them up. It'll make it easier for you to identify alpha and beta if you split them up. So, do that if you need to. And then here you have it. So you can see here alpha is 1/2 and beta is square root of 3 over 2. Okay? Because remember, see, there's your alpha and beta is the number in front of I. All right, so we've got y equals c1 e to the 1/2 x, that's alpha to the x, cosine square root of 3 over 2 x, see, I just plugged that in for beta, plus c2 e to the alpha times x, so 1/2 times x times sine of beta, square root of 3 over 2 times x. And there's your solution. Okay? So, I mean, you know, if you think about it, the hardest part in these problems is just solving the auxiliary equation. And that's just algebra. All right, let's look at the next example. All right, so let's see what we've got here. We've got, that's going to be what? M cubed plus 4m equals 0. And so we solve it. We get m times m squared plus 4 equals 0. So m equals 0 or m squared plus 4 equals 0. So m squared equals -4. So m equals plus or minus the square root of 4. So that's plus or minus, the square root of -4. So that's plus or minus 2i. And if you want to, write it as 2i or m equals -2i. Either way, it doesn't matter. Okay, or you can leave it plus or minus. All right. Now, the thing that you do here is, you don't have to do this, but note that this, because remember where m equals alpha plus or minus beta I. So if you need to, write this as 0 plus or minus 2i. See, there's no alpha there, so it's alpha 0. All right. All right, so we've got m equals 0, and then we have a complex solution. So here we've got y is equal to, so that's going to be what? C1 e to the 0x. That's for this m equals 0. Plus, and now we go to our complex solution. Alpha is 0, beta is 2. So that's going to be C2 e to the 0 times x times cosine beta x plus C3 e to the 0x sine 2x. And so we get y equals C1 plus C2 cosine 2x, because e to the 0 is just 1, plus C3 sine 2x. And this will be your solution right here, because remember, this term is 1, this term is 1, and this term is 1. And so that would be your answer there. Okay. All right. And you know, I'm writing C2 cosine 2x, C3 sine 2x. Let me show you here for this one. This solution here, you can also write this solution as y equals C1 e to the alpha x sine beta x plus C2 e to the alpha x cosine beta x. It doesn't matter if you write the cosine or sine first. Okay, you're going to get the same answer either way. All right. So moving right along. Okay, so here we have, we're going to actually find the particular solution here. They give us conditions for y prime and y when x is equal to 0. So first thing, we've got our auxiliary equation, m2. M squared, minus 2m plus 12 equals 0. And we can use quadratic formula here. And we did use the quadratic formula earlier, but what I want to do here, instead of using the quadratic formula, which perfectly fine if you do that, let's complete the square on it. Remember how to do that? Most students don't like completing the square. So we've got m squared minus 2m equals -12. Leave that space there. So we half the 2, which is 1, square it, that's 1. Add 1 to the other side. So that's m minus 1 squared equals -11. So m minus 1 equals plus or minus the square root of -11. Add the 1 to both sides, and that gives me m equals 1 plus or minus I square root of 11. All right, so there's our solution. So we get y equals C1 e to the 1 times x. See here, alpha is equal to 1, beta is equal to 11. I'm sorry, square root of 11. And then that's going to be cosine. And I tell you what. Now, I was going to say, let's write sine first. Let's just keep it like this. That's going to be square root of 11x plus C2 e to the 1 times x sine square root of 11x. And so y equals C1 e to the x. I'm just doing 1 times x is x. That's all I'm doing in this step. Cosine square root of 11x plus C2 e to the x sine square root of 11x. All right, so this problem is going to be a little more involved. Okay, so we know that when we plug 0 in to this, we should get 1 as an answer, y equals 1. So basically, this is telling us, this right here is telling us that y of 0 is equal to 1 and y prime of 0 is equal to 2. That's what that's telling us. So we need the derivative of this thing. I know I don't want to do it either, but we have to. We got to take the derivative of this. So for each of these, we got to use the product rule. All right, so we got y prime is equal to, so what I'm going to do is I'm going to keep this as my first function, this is my second function when I'm doing the product rule here. And same thing here. This is going to be my first function. This is going to be my second function when I'm doing the product rule. All right, so it's the derivative of the first. So derivative e to the x is e to the x times cosine square root of 11x plus, and then derivative of cosine is negative sine times the derivative of what you're taking the cosine of. So the derivative of square root of 11x is square root of 11. And so this is going to be negative square root of 11 sine square root of 11x times C1 e to the x. All right. So this right here is the derivative of this first term here. And then we've got to do the same thing here. We've got to take the derivative of this using the product rule. So that's going to be plus derivative of the first, C2 e to the x, sine square root of 11x, plus, and then derivative of sine is cosine, and that's square root of 11 cosine square root of 11x times C2 e to the x. I had to squeeze it in there. Well, come on and erase. All right, so now let's just clean this up. Let's rewrite this. So y prime, that's C1 e to the x cosine square root of 11x minus square root of 11 sine square root of 11x. Whoop, I'm sorry. Let's write the C1 e to the x first. C1 e to the x let's do this. C1 square root of 11 e to the x sine square root of 11x plus, that's going to be C2 e to the x sine square root of 11x plus, and that's going to be C2 e to the x C2 square root of 11 e to the x cosine square root of 11x. All right, so I'm going to pause the video, check my answer one more time because I don't want to write this down wrong. All right, so we're good now. We're good to go. All right, so now we've got to use these conditions here. So we got to plug 0 in for x right here and set that equal to 2. So I've got y of 0 is equal to c1 e to the 0 cosine square root of 11 times 0 plus c2 e to the 0 sine square root of 11 times 0. Now, thankfully, this right here, this term here, oh, I'm sorry, and that equals, what does that equal? That equals 1. And thankfully, this right here goes to 0 because sine of 0 is 0. Now, this right here, well, let me change colors back. This right here, that's e to the 0 is 1. Cosine of 0 is 1. And so this tells us C1 is equal to 1. So that wasn't bad. So now we have to solve this one. We've got to plug the 0 into here. So we've got y prime of 0. All right, so let's look at this. Let's plug the 0 into here, but keep in mind C1 is 1. So we're going to replace this with a 1, and we're going to replace this one with a 1. Okay? All right, so that's going to be e to the 0 cosine square root of 11 times 0 minus, and that's 1, that's square root of 11, e to the 0 sine square root of 11 times 0. Now, look, I mean, if you want to, you can say, well, that's 0, and this one's going to be 0, and I'm just going to be left with this one and this one. You can do that, but we'll plug everything in. All right, plus, and then that's C2, e to the 0, sine square root of 11 times 0, plus C2, square root of 11, e to the 0, cosine square root of 11 times 0. Oh, I'm running out of room. All right, so right off, we can scratch this out. That goes to 0, and we can scratch this one out. That goes to 0. Oh, I'm sorry, and that is going to equal to 2 when we plug 0 into the derivative. That equals 2. And so this tells us that, let's see, that's 1. 1, that's going to be 1 plus, and then that's going to be C2, that's 1. That's 1, so that's going to be plus C2 square root of 11 equals 2. So this tells us that C2 square root of 11 equals 1, which means C2 equals 1 over square root of 11. All right. And if you want to rationalize denominator, you can do that too. Multiply numerator and denominator by square root of 11. And so for our final solution, we get y is equal to, and here's our solution. We just plug everything in. So C1 is 1. So that's e to the x cosine square root of 11x plus C2, which is square root of 11 over 11, e to the x sine square root of 11x. And this should be your answer. All right. So, you know, that wasn't too bad. And I know if you're in my class, you're probably asking, well, do you want us to rationalize the denominator? Well, I guess since I did it in the video, you can go ahead and rationalize denominator also. All right. All right, so let's take a look at this one. All right, so we've got m cubed plus 3m squared plus 3m plus 1 equals 0. Oh man, now how do we go about factoring this? Well, I'm not going to go through all the steps, but one way that you can do this is you can look up solving polynomials using synthetic division. You can search for that video on my channel and it'll show you how to do it. I'm not gonna go over it in this video because it takes a little while to solve these things, those equations. So you know, that's that. But yeah, if you want to know how to solve this out, see all the work, just watch that video and it shows you how to solve what I'm fixing to write down. But when you factor this, this is going to be m plus 1 cubed equals 0. That's what you get when that factors. So, you know, it is what it is. So look at this. We get m equals -1, but remember we have 3 factors of it. And like I said before, now this you don't have to do, but if you want to write it out, like this, you can if it helps you. Okay, so that gives us m equals -1, or m equals -1, or m equals -1. Okay, so we've got repeated roots. We got 3 of them. So I wonder what that's going to be. Well, that's y equals c1 e to the -1 times x plus c2 what? X e to the -1 times x plus c3 x squared e to the -1 times x. So we get y equals c1 e to the -x plus c2 x e to the -x plus c3 x squared e to the -x. And this is our solution. All right. And now the last problem. All right. So this last problem, it's not going to be difficult. What is that? Plus 4. Not m to the 4th. M squared times m squared plus 4 equals 0. So look at this. We get m squared equals -4, or m squared equals -4. So m equals plus or minus 2i, or m equals plus or minus 2i. We've got repeated complex roots, don't we? All right, so I wonder what this is. Well, this is just going to be y equals c1 e. Now, in both cases, alpha is 0, beta is 2. Why did I put it equal? c1 e to the 0 times x cosine 2x plus c2 e to the 0 times x sine 2x plus, okay, so that takes care of that one. Now we've got this one over here, and so that's going to be what? c1x e to the 0 times x cosine 2x plus c2x e to the 0 times x sine 2x. And so just cleaning it up, y equals c1e cosine 2x plus c2. Oh, I'm sorry. What am I doing, you big dummy? E to the 0, all these e to the 0s are 1. I don't know why I put e to the x. All right, so that's going to be c1 cosine 2x plus c2 sine 2x. Whoop, I'm sorry. Look at that. I messed up again, didn't I? That should be, I got c1, c2, that should be c, I got C1, C2, that should be C3, and that should be C4. Luckily, I caught it. I would have heard that in the comments. All right, and then we've got C3x cosine 2x plus C4x sine 2x. And this would be your solution. All right, so that's all of this video. You can see it's pretty easy. It's, you know, mainly just solving quadratic equations or polynomials, something like that, what you learned in college algebra. We had one up here where we found the particular, this one right here, where we had to take the derivative. That one got a little nasty. So you can see they can get nasty, but for the most part, they're not too bad. So I hope this video helped. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching, and I'll see y'all in the next one. Later.